This week's test review will be over part A of polynomials. The first thing we're going to do is look at the example, rewrite in standard form, identify the leading coefficient, and then we're going to name it. So standard form requires you to look at your highest exponent, and then you will count in descending order or count down. So everything that's attached to that exponent, that is considered a term. So that's going to go together. And when we rewrite it, it's going to be 9x to the fifth, and then the next exponent below that is 4, so negative 2x to the fourth power, then 3 plus x cubed. We don't have a square or a power of 2, so we can just go to our constant, which is negative 6. This is standard form. Identify your leading coefficient. The coefficient that's in front of your variable with the highest exponent is your leading coefficient. So in this case, our leading coefficient is simply 9. And then the next one, the next set in the direction said to name it. I'm looking again at my highest exponent, which is 5. So that means that it's going to be a quintic. And because of the terms, I have 1, 2, 3, 4 terms. So that is known as a polynomial. So it's called a quintic polynomial. That is my name. Okay. The next example is asking to find the remainder using synthetic division and the remainder theorem. So as I taught you in class, if you can set the divisor, that's your divisor, equal to 0, that will tell you what your x value is. It's always the opposite sign. So here, x is going to equal 3. You use synthetic division when your leading coefficient in front of your divisor is 1. So I'm going to take this 3 and I'm going to, excuse me, put it over here, which is where my divisor is located. X is 3, so that's my divisor. What goes next to that are my coefficients. My coefficients are the numbers that are in front of the variables, including the sign, as well as my constant. So those are the items that I'm going to put next to my divisor, just the numbers. So I have 2, negative 5. Now what I have to pay attention to is I notice I have 4, 3, and then it skips to 1. Well, I have to put a 0 placeholder because I have to account for all of my exponents. So for x squared, there's going to be a 0. And then I continue, negative 7, and then positive 9. This last number or last column, this will be my remainder. So whatever's here is going to be my remainder. The way you start the process is you take your leading coefficient and you bring it down. Everything that's below the line, you multiply it times your divisor. And everything that's above the line, you just add it down. So 2 times 3 is 6. 2 times 3. And then you put your answer above the line. Now I'm going to just add down. Negative 5 plus 6 is 1. Start the process again. 1 times 3, 0 plus 3, 3 times 3, negative 7 plus 9, and 3 times 2, which is a positive 6. So again, what's left over in this last column is my remainder. So we found the remainder using synthetic division. We're going to also use the remainder theorem. So you can use either or depending on your directions. Well, we already know that our divisor, or not even the divisor, we already know that x is 3. So what the remainder theorem is simply asking us to do is just find my x and substitute it with the 3. So it's going to look like this. Wherever I see an x, I am going to replace it with a 3. 2, 3 here to the 4th, minus 5. I see an x, so I'm going to replace it with a 3. Sorry about that. I have to change my setting up here. Okay. So I have a 3 there, and that 3 is raised to the 3rd power minus 7 raised to the 3rd power plus 9. I'm just simply following these instructions here. And every time I see an x, I'm replacing it with a 3. Then what I want to do is simplify it. So, excuse me, if you put it in a calculator, it'll do it for you. If you put it exactly how I just wrote it out. Otherwise, it's 2 times 3 to the 4th power, which is 81, minus 5 times 3 to the 3rd power, which is 27, minus 7 times 3, which is 21, plus 9. And let's simplify that. I have to get out my calculator here. So I have 162 minus 135 minus 21 plus 9. And now let's go ahead and simplify this. 162 minus 135 minus 21 plus 9. And it will result in 15, which is the same thing we said when we used our synthetic division. So there's more than one way. I always tell you there's more than one way to do your math problems. I like to give you options. All right, so use long division and the area model to find the quotient. So this is the problem that we're going to work with. We already know the divisor goes outside and the dividend goes inside. Again, pay attention to the 0 placeholders. First step with long division is you're going to take your first term under your division sign and divide it by your first term of your divisor. So what that looks like is 15x to the 4th divided by 3x. And the exponent you start with is going to count down by 1 degree when you start your answer. So 15 divided by 3 is 5. And x to the 4th divided by 1 is simply subtracting the exponent, so it's x to the 3rd power. I like to align mine up, so I'm going to go over to where it's x to the 3rd power, and that's where I'm going to put my answer. What I also like to do is, well, not like to do, my steps are going to be divide, multiply, subtract, and bring down. So when I just divided, now I'm going to multiply my quotient, part of my quotient, times the entire divisor. Everything that's up here times my divisor, those are my factors, okay? And my factors will multiply to give me my dividend. Well, possibly a factor. This, if it has a remainder, then it's not a factor. This isn't a factor. All right, so now I'm going to multiply. So 5x cubed times this entire thing. And when I get that, I'm going to write it down here. So 15x to the 4th, and it should be exactly the same if I'm doing it correctly. So 15x to the 4th, 5x cubed times 2 is going to be plus 10x cubed. My next step tells me to subtract. Well, when I subtract, that just simply means I am changing the sign. So this is a negative, and this becomes a negative. This one will go away. Now I just continue doing my math. I have negative 6x cubed, and I bring down negative 16x squared. Start the process again. Take this first term only, negative 6x cubed, and I'm still dividing by the first term of my divisor. So it's going to always be that at the bottom in my denominator, 3x. Negative 6 divided by 3 is negative 2. X cubed divided by x is x squared. This goes above my x squared. Start the process again. Multiply the negative 2x squared times the entire divisor. Take that answer and I place it here. So that's negative 6x cubed. Again, they should look exactly the same. Negative 2x squared times 2 is negative 4x squared. My next step tells me to subtract, which simply means changing the signs. This one goes away. I'm left with negative 16 plus 4, which is negative 12x squared. Bring down my next term. Start the process again. Divide negative 12x squared divided by that same 3x is negative 4x. I put this above because that's my quotient. And I'm going to take the negative 4x and multiply it times my divisor, all of my divisor. And that ends up being negative 12x squared minus 8x. My next step after multiplying is to subtract. That simply means, again, change the sign. So this becomes a positive, this becomes a positive. That goes away. And I just simplify. 16 plus 8 is 24x. Bring this down, plus 12. And start the process again. Dividing. 24x divided by 3x. The x's go away, and there is an 8 left there. So plus 8. I have signs in between each of my terms. What is going on with this thing? All right, so I have signs in between each of my terms, and my exponents are counting down. 3, 2, 1, and then I don't have an x. And I have to keep going because what I just did was divide. So my next step tells me to multiply. When I do that, I end up with 24x plus 16. And I have to change the signs because I have to subtract. Subtract, subtract. That's going to go away, and I am left with a -4. Now, with this -4, that's my remainder. So I have nothing else to bring down. I am going to put -4 all over my divisor. So it has to be in fraction form, your remainder, x plus 2, 3x plus 2. This is how I like to write it, but there are cases that I have seen where someone will write the negative next to the 4 and then put a plus next to that. I don't like it that way, but it's not wrong. Okay, so let me go ahead, and you have to account for this negative sign. That's using the long division method. So let's try the area model method, which we still are using as long division, because if your leading coefficient is greater than 1, you can't use synthetic division. Well, we're not going to use synthetic division. That's what I'll say. All right, so my divisor is going to go vertically, 3x plus 2. Then I go to my first term of my dividend, and that is going to go in my first box, 15x to the 4th. Now I'm just going in reverse for my area model. So what I do is every time I'm dealing with the first row, I'm dividing. Every time I'm dealing with the second row, I'm multiplying. So I'm going to take 15x to the 4th. I'm going to divide it by what's on the outside. Whatever that answer is, that's part of my quotient. So that's going to go at the top. So 15x to the 4th divided by 3x is going to leave me with 5x cubed. And you should know that you're doing it right, because again, if you started with the 4, it's going to go down 1 degree. If you started with the 3, it's going to go down 1 degree to 2. All right, now you take that information and you go to the second row and multiply. So 5x cubed times 2 is positive 10x cubed. Now, this is the part that is kind of tricky. So what I want to do is try to combine these two terms, because this is also going to have to be x cubed. Diagonally, they will have the exact same variable and exponent. I'm going to go back up to my dividend, and I see that I should have a 4x cubed. So I have to try to figure out 10 plus what will give me that 4x cubed. Or I can work backwards and say 4 minus the 10 that I already know is what? So this will be negative 6x cubed. And again, 10 minus 6 gives me that 4x cubed. Now I start the process again. I take this box and I divide it by what's on the outside. Negative 6x cubed divided by 3x is going to be negative 2x squared. Negative 2x squared times 2 is negative 4x squared. I'm again looking for two items that I can combine for my x squared so that I can find a negative 16x squared. So negative 4 plus what will give me negative 16, or negative 16 minus this negative 4, which that will turn into a positive, will give me what? It's going to give me negative 12, right? So negative 12x squared, that's what goes there. I take that information divided by 3x, negative 4x And yeah, 4x. I know that I'm doing it right because it's counting down 3, 2, 1. So I know my next item is just going to be a constant. And now I take that negative 4x, multiply it times the 2, negative 8x. This is also going to be an x. I have to try to figure out what will make negative 8 plus what will give me a positive 16. So again, working backwards, you can just say 16 minus negative 8. This is really going to be a plus, so it's going to be 24. So whichever way you see it, if you see negative 8 plus 24 automatically, then that's the way you want it. Otherwise, just work in reverse, 16 minus whatever. So 24x divided by 3 is positive 8. And like I said, it's just going to be a number. And then 8 times 2 is 16. However, I'm looking for a 12. So I have to continue. Really, I'm finished dividing because once my exponent here, my x to the first power and this one are the same, that means I'm finished the division part. Now anything else over here, that's my remainder. So 16 plus what will give me 12? Or working backwards, 12 minus 16 is negative 4, right? So we'll just write that in a different color. 16 minus 4. My actual answer is on top. However, that negative 4 is my remainder. So therefore, my divisor has to go under it. So that's going to be 3x plus 2. This is what we just did a few minutes ago. The only difference was we used a different method. So look at this one for area model and then compare it to this. Same thing. Okay, just two different ways of doing it. You can rewind, fast forward, whatever you need to do so that you can get a better understanding of it. All right, so this time we're asked to find k. So k could be anywhere. In this case, it's your constant. So we're trying to find it to make the linear expression a factor. Remember, I told you in class, if it's a factor, you will not have a remainder. The remainder will be 0. So we're going to do this two ways. If we solve for k, then what we're saying is here we already know that if we set b minus 7 equal to 0, it's going to be the opposite sign. So b is 7. When you're solving, in this case, you're just going to be substituting. So f of 7 is equal to, every time I see a b, I'm going to replace it with that 7 and then follow the directions that are given. So this 7 is raised to the second power. Then I have negative 8, another b, which I'm replacing with the 7, but I have a k here. That's what I'm trying to find. Trying to find this k. So let's just simplify. So 7 raised to the third power. Let's see, 7 raised to the third power is, if you're manually doing this, again, if you just put it in the calculator, it's going to give you 42. But let's just go ahead and do it. So 343 minus 5 times 7 squared, which is 49, and minus 8 times 7, which is 56, plus k. Well, since I know that I'm trying to make it a factor, I'm going to go ahead and set it equal to 0. Because again, that means I will not have a remainder. What I would do now is just simplify. 343 minus 5 times 49 is 245 minus 56 plus k is still equal to 0. Once I combine my like terms, again, that is going to be 42 plus k equals 0. Well, I want to solve for k, which means that I'm going to have to subtract this 42 on both sides, which leaves me with k being 42, negative 42, sorry. So k is equal to negative 42. That is when I use the solving method. If I wanted to use the synthetic division method, well, I still understand my divisor is 7. It's the opposite sign of what's shown here. What can I put in the place of that b to make that equal 0? Then I use my coefficients from my dividend. 1, negative 5, negative 8. And I don't know what this is. This is what I'm trying to find. I'm trying to find K. Remember, make sure that you have all of your exponents accounted for. If not, you need to use a zero placeholder. First step, bring down your leading coefficient, multiply it times your divisor, then add down. So that's 2. 2 times 7 is 14. Negative 8 plus 14 is positive 6. 6 times 7 is 42. So in order for this to be 0, my K would have to be the opposite sign, which is negative 42, which is the exact same thing that we came up with the other method. And here we're going to perform the indicated operation. We are given f of x, g of x, and h of x. So what we're going to do is just follow the directions. Know that this really is like you're distributing, right? So this is really f of x minus g of x. I find it helpful to rewrite it like this. And now what I do is just take f of x, and I'm going to substitute what's shown, which is x squared minus 3. Now this part, pay attention, wherever this negative sign is, if it's in front of what's following it, everything in that function will change. So all of g of x, all the signs will change, that's what I mean. So instead of it being a positive x, it's going to be a negative x. So I'm just going to go ahead and write it down that way. Instead of it being a positive 5, it's going to be a negative 5. And now simplify. I have x squared minus x, and I can combine the negative 3 and the negative 5. Signs are the same, so that means you're adding and taking that sign. And this is your final answer, and it's already in standard form. The next part for number 2 is asking me to take g of x and add it to h of x. Simple enough, right? G of x is x plus 5. H of x is 3x plus 2. And then I'm just told to add it. So that's what I'm going to do. Remember, there is a 1 right here. So when I add down, this is 4x plus 7. That's my answer. When I go here, I have to be careful. Look at what's shown. It's not always in alphabetical order, so you have to pay attention to the details. So they want me to take 2 times h of x. So let's go back up and see what h of x is. It is 3x plus 2. So I'm going to take 2 of those. 3x plus 2. So that means I'm going to distribute this 2 to everything inside of the parentheses, which results in 6x plus 4. So now, once I get that answer, I'm going to subtract it from f of x, meaning everything that's in f of x now changes sign. So instead of positive x squared, it's going to be a negative x squared. Let's go ahead and write that down. And I'm lining it up with like terms if there's something there. Instead of a negative 3, it's going to be a positive 3. It's the opposite sign when there is a negative sign in front of the function. Now I add down. I have a negative x squared. If you wanted to, you could put a 0 placeholder. It's not required. 6 plus 0 is 6x, and then 4 plus 3 is 7. That's your answer. This one, again, it's helpful to rewrite it. G of f of x. What that simply means is this is really g of x, right? One big g of x. For x, they want all of f of x to be replaced inside of the g function. So we're going to go back up to g, and we see that it's x plus 5. So g is x plus 5. Well, we want to replace that x with all of f of x. What's f of x? Go back up. X squared minus 3. So that's what we're going to replace. X squared minus 3. And then it told us to add 5 to that. So this is the g of x. We're taking all of f of x, which is this part, and we're just replacing that x and then following the rest of the instructions, which is to add 5, I'm sorry. Okay, Y'all follow me? So now I just simplify. And I end up with x squared. -3 plus 5 is +2. And that's my answer for that one. Now let's go to the next set of directions. Find each product. So for me, there's more than one way to do it. So what I'm going to do is I'm going to FOIL the first two, and then I'm going to use the box method. You don't have to go in that order. You can use any two at the same time. Or so if I wanted to start here, I could. If I wanted to start here, I could. That's what I'm going to do. I'm going to start on these two. So for those people who like to use the distributive method, you have 4 things happening. So what I end up with is 3x squared minus 12x minus 2x plus 8. I take this answer, and now I'm going to do the box method. And well, after I combine like terms. So I have some like terms here. Don't leave it this way. So what I would do is 3x squared, -12 plus -2 is -14x plus 8. And now I'm going to use the box method, and I'm going to take my x plus 1, which is remaining, and I'm going to multiply that answer by that. When I do that, I end up with 3x to the 3rd power minus 14x squared plus 8x. That's for my first row. All I did was multiply by everything that's on top. And then on the bottom, I just take 1 and I multiply times everything. Well, 1 times anything is itself, right? So it's still 3x squared, still -14x, and it's a positive 8. So now when I combine my like terms, I see diagonally, I have some x squareds I can put together. I see that I have some x's that I can put together. My final answer in standard form, starting with the highest exponent, is 3x cubed. -14 plus 3 is -11. X squared. -14 plus 8 is -6x. And then finally plus 8. Again, pay attention to my exponents. They're going down 3, 2, 1, and then there's not any. Here, I can do the same thing. I can either distribute or I can use the box method. I'm going to use the box method. And instead of rewriting it, I'm just going to take 3p plus 1, put it on the side, and just create my box from what's already above. So 3p times p squared is 3p cubed. 3p times -5p is -15p squared. And 3p times 4 is positive 12p. Go to the bottom, and again, 1 times anything is itself. So p squared minus 5p plus 4. Combine if I can, which I can in this case. They're in standard form, so I can combine my p squares, I can combine my p's. My final answer in standard form is 3p cubed. -15 plus 1 is -14p squared. 12 minus 5 is plus 7p. And then finally, the last box, plus 4. Now I can also expand using Pascal's triangle. I've already set up the triangle. There's another video that tells you how to set it up if you forgot. If your directions did not specifically tell you to use Pascal's triangle, you could have just written this 3 times. So that's what that means. Take your expression and multiply it times itself this many times, okay? And then you could use the method I just showed you. You can either distribute it and use a box. You can use the box 2 times. You can distribute it 2 times, whatever works for you. But since this direction, this set of directions specifically say to use Pascal's triangle, that's what we're going to do. And the way I use it is y plus 5, which is what's in the parentheses. And above it, I use my row for the exponent that's shown. So I'm going to use my coefficients 1, 3, 3, and 1, and I'm going to leave some space like I just did. For every box, I am going to fill it in with what's shown here. So what's shown there is y. So this is going to have a y, this is going to have a y, y, and a y. So above, I have what's called coefficients. Those coefficients will come down into my first row only. I don't have to put the 1 in front of the y's. Now I go to my exponent and I start with that and I count down. 3, 2, 1, 0. Anything to the 0 power is automatically 1. Now I go to my next row and whatever's on the outside, including the sign, goes in every box. You do not use the coefficients that are above the table, only what's shown here. So now I go in the opposite direction, starting with 0. Anything to the 0 power is simply 1. So that is 0, 1, 2, 3. Now I can simplify this. 5 to the first power is simply 5. 5 to the second power is 25. 5 to the third power is 125. Sorry about that. That was kind of messy. Fix my box. All right, and then at this point, all I do is multiply down. So in multiplying down, my answer is going to be y, let's just change it, y cubed. 3 times 5 is 15. And then I have a y squared. 3 times 25 is 75. And you always have to have signs in between. And I have 1y. And 1 times 125 is 125. That is my answer. And again, I am counting down 3, 2, 1, and then there's no y's left, okay? This is using Pascal's triangle. I'm asked to find the third term of this. They're showing me something, but I only need the third term. I'm looking for the row in my Pascal's triangle that has the exponent of 4. So let's go ahead and just start setting up my table. I have y minus 2x going down to the side. If I go back to my Pascal's triangle, I'm using these numbers this time: 1, 4, 6, and 4, 4, 1, except I don't need all of them. I'm only looking for the third term, so I'm just going to do 1, 4, and 6. 1, 4, 6. You really don't even have to do all of that. I just like to start I like to start off with 0 to, not 0, y to the 4th power this time, because again, I'm using this exponent that's shown there. And I know by the time I get to the third term, that is going to be to the 2nd power, because again, this would have been y to the 3rd power. I don't need that, but this is just a guide. I had to bring this 6 down because that's my coefficient. So I'm finished with the top. Now the bottom part can be tricky. You have to put this in parentheses. So you might want to just make it a habit of doing that so you won't forget. Negative 2x is going to be raised to the 0 power, and that's simply 1. So I know I'm counting up this time. By the time it gets to the third term, it's going to be 2. I know I'm doing it right because 2 plus 2 equals my exponent. So when I'm adding down, it has to equal my exponent. Now I just simplify. Negative 2 raised to the 2nd power, this is where people sometimes forget, that's why you have to use parentheses, is going to be 4. And then x is also raised to the 2nd power. So it is x squared. So this is what I'm working with. I am multiplying down. 6 times 4 is 24. And then I go from top to bottom. So y squared, x squared. That is my answer for the third term. I'm asked to find the perimeter and the area of this figure. So the perimeter simply means adding all of the sides. So you see that you have information for the top and for the left-hand side, but you don't necessarily see anything on the right and the bottom. But remember, it's a rectangle. So what the top is, the bottom is. What the left is, the right is. So you can just double it. So this is what I'm going to do. I recognize that I should actually go ahead and put plus signs here, because one part plus another part equals the whole thing. Now, if I'm adding, I'm going to take, and it doesn't matter which order you do it in. So for my perimeter, I am going to take 4 plus x and multiply it times 2. That's going to give me 8 plus 2x. And for my top portion, I'm going to go ahead and combine those x's. So that's really 2x. So I have 2 times 2x plus 5, and distributing this, 2 times 2 is 4x, and then 2 times 5 is 10. Notice I had to write it the other way around because I'm trying to combine like terms. Now this is 18 plus 6x. I want it in standard form though, so I'm just going to rewrite it with the x first, and my answer is 6x plus 18 for my perimeter. For my, you could have set and added like, there's 2 x's here, so there's going to be 2 x's on the bottom, so that's 4. There's 1 x here, and then there's going to be 1 x on the other side, so that's another 2, so that's 6. You could have done that and then added 5 plus 5 is 10, and then 4 plus 4 is 8, so that's 18. It's more than one way to do this. For my area simply means, in the case of a rectangle, length times width. So I already know what I'm working with because I simplified it already above in my perimeter. So all I have to do is just multiply those numbers. I'm going to take 4 plus x, and I can multiply it times 2x plus 5. Again, there are 2 x's here that I'm adding. That's where I'm getting that 2x from. And now once you multiply this out, if you choose to use this method, I'll go ahead and do that for now. Then you're going to end up with 8x plus 20 plus 2x squared plus 5x. And you notice it's not in standard form. So go ahead and get your highest exponent, and then you want to combine like terms. So you have an 8 and you have a 5x. So you want to combine that. 8 plus 5 is 13x, and then your constant is 20. That is in standard form for your area. Moving on. So now we're going to find the inverse. The inverse simply means you swap your x's and your y's first. So f of x really is y. So we're going to swap that with x. X is equal to the cube root of, and we're going to change this to a y, minus 1, plus 2 is on the outside. What I want to do is solve for y. So swap x's and y's, solve for y. Now I'm going to undo things. So I'm going to subtract 2, subtract 2. That gets rid of that. I'm left with x minus 2 is equal to the cube root of y minus 1. To get rid of the cube root, I do the inverse, which is 2 cube. What I do to one side, I do to the other. That gets rid of that, and I am left with the quantity of x minus 2 cubed is equal to y minus 1. Y is still not by itself, so in order to make it be by itself, what I have to do is get rid of this 1. So I'm going to add 1 to both sides. That 1 is not included in the set of parentheses. And I am going to rewrite this y as f inverse of x is equal to all of this, which is x minus 2, the quantity of x minus 2 cubed plus 1. That's my answer for the inverse. Let's do this one. First step, swap your x's and y's. So this becomes an x, this becomes a y. And then I'm solving for y. So I want to undo. Negative 2, negative 2. This side becomes x minus 2 equals y cubed. Well, I just told you the inverse of a cube is a cube root. Well, I said the inverse of a cube root is cube, but same thing. What I do to one side, I do to the other. My y becomes f inverse of x is equal to the cube root of x minus 2. That's that answer. All right, so now we have a graph, and we are following the directions for the composition functions. So what is that going to look like here? This is the same as saying f of negative 3. So what I'm doing is, remember, this represents X. So for my X on the F graph, I'm looking at -3. And then I'm looking for the output, which will be right here. That is 1. So I'm going to rewrite this as 1, but my directions tell me to take F of 1. So now I'm going to go to where my X is 1 on my F graph, and then find the output, which is again 1. So the answer here is 1. Looking at the same graph, this time I'm asked to take the inverse. So G inverse of 3, where Y, so the inverse is, instead of being X, is going to be Y. So where Y is 3, what is my X value? And it's going to be -1. So where Y is 3, what is my X value when we're talking about the G? And that's it. All right. So this is going to help you for your test. I know it was very lengthy, but again, fast forward, rewind, do whatever you need to do, and so that you can get a good grasp on this. And I hope you have an awesome day or night.